All right, welcome everybody to another live stream back in school. My name is Brian McLogan, and I am going to do cover a quiz that I gave last week to my students on applications of trigonometry. And basically, what we kind of covered over in this quiz is doing solving word problems just with right triangles, as well as solving triangles using the law of sines or oblique triangles. Solving using the law of sines as well as the law of cosines, as well as finding the area of the oblique triangle. And I believe that was everything on the quiz. Yes, that was. So we have 4 free response, which are all word problems. So lovely in case you need some practice with how to set up word problems and go ahead and solve. That's what we'll do on there. And then on the back side, we have some multiple choice, which again, I think 3 of them. 2 of them are going to be word problems as well. So we'll definitely go and get some practice with that, get some practice with some bearings. Overall, students did decently well. At least, my main thing is when we're doing these word problems, guys, is setting up the equation, setting up the triangle correctly. So therefore, you can go ahead and solve it. So I still have some of these to grade, so I'm not going to want to spend too much time on this live stream. So I'll try to explain myself as best I can for those of you that kind of need some explanation on what I'm doing. But I do want to make sure I go through. I'm not sure how much time I'm going to have as far as answering some additional questions for you guys. However, I do plan on going live this week on Tuesday and Thursday, so I will try to make some posts here on my Facebook page as well as in my members kind of area on my YouTube channel. So therefore, if you'd like a copy of this work as well as to post some answers, I'll make some posts at least on my YouTube memberships for those of you that are interested, and then otherwise also for those of you on Facebook, you can go ahead and work out as well. So see, some of you guys have now joined in. So Gregory, Dragon, Dadi, Amir, Sophia, Jack Thomas, Veriflux, the Kitty Gamer, Princess Emerald. Man, there's a lot of you. Good to see you guys. All right, so let's go ahead and get started and go through here. So I'm going to show some work. I will show some work, at least how I'm setting up. My main thing that I asked students to do was, provide me the triangle, provide me the equations, and then I will assume majority of the stuff you can do with a calculator. So this is the calculator that I have at home. Usually in my class, we go through using a TI calculator. But therefore I'll go through there. So I'm just going to kind of show the work that I at least did. I'm going to kind of look at my key just to make sure I'm kind of following through what I did. And then we'll kind of go from there. And if you guys have any questions, obviously as I'm going through my quiz, just make sure to go ahead and post them. And then before I get to the multiple choice, I'll just go ahead and check real quick and make sure that I don't need to elaborate anywhere for you guys. All right, so I'm actually going to zoom in here real quick for this one. So the first question says, an observer in a lighthouse, which I should actually zoom back out. An observer in a lighthouse 350 above sea level observes 2 ships directly offshore. The angles of depression is 4 degrees and 6.5 degrees. So the angles of depression really got a lot of students on this quiz. So just remember, let's say here's the top of the lighthouse. Okay, so just do a lighthouse. And I said, draw a picture, guys. That's the main thing. Just draw a picture, have fun with it. So this lighthouse is 350 feet. All right. Now, again, there's an observer in the lighthouse that observes 2 ships directly offshore with angles of depression. Now, remember, angles of depression are from a horizontal. So this person up in the lighthouse, we have to create a horizontal. So here's going to be my horizontal line. So therefore, I'm going to have 2 angles of depression. And again, these are of 2 ships offshore. So here's kind of like the water. Okay, so we have 1 ship here. And let's just do another ship here. Here is their observation. Okay. So for the smaller one, obviously that's going to be 4 degrees. And for this other one is going to be 6.5 degrees. So those are your 2 angles. Now, you could have done your triangles any different way you wanted to. I showed this in my homework one way, and I showed it in class another way. So whatever way that you either caught or which made more sense to you is perfectly fine. So the way that I'll do it in the quiz is like what I did in my class. Since I didn't record that, I only recorded the one on my homework. So basically, again, guys, we need to create some triangles. So all I'm simply going to do is if I create a vertical, horizontal here, here. Now you can see I've created two triangles and I know what this angle is. For this smaller triangle here, my angle is 6.5. And for my larger triangle here, my angle is 4 degrees. And a lot of students tried to use the triangles down here, which is fine, but they made a mistake when using their complementary angles. So they didn't get the complementary angles correct. I don't want to write it in there because I don't want to get confused. But you could have done it that way as well. But a lot of people that made their mistakes, they didn't get the complementary angle correct, as I keep on saying that over and over again. So just remember, if that's 350, then over here is 350. Okay, right? The height is still going to be the same. And then the question is, how far apart are the ships? So let's call the distance the ships are D, right? Actually, let's put that down here. Oops. So here is D. All right. Now, the important thing to understand here is we have two triangles, right? So we have this triangle right here where this length we can call D1, right? And then we have this other length over here, which is the orange, which would be D2. So they're both different sides of the triangle, and therefore we can just say D is equal to D2 minus D1. If I subtract D2 from D1, that's going to give me my distance D. And D represents the, basically I told my students to write out what you're solving for, so how far the ships are. And because, how far the ships are. There we go. So it doesn't tell you how far the ships are D, so therefore we just want to make sure we're clarifying our variable D, which we're going to solve for. So now we basically want to create our trigonometric ratios. So if we look at this larger triangle here, now typically I guess I could redraw these out. I guess I do have a little bit more room. Let me actually let me try to do this. Let's fit back to width. Okay, so let's go ahead and maybe draw out our two triangles again. So let's relabel them. So we have the big triangle. Okay, and that one is at 4 degrees. This is D2, and that's 350 feet. And then we have the other triangle, which is a little bit bigger angle. That's D1. This angle is 6.5, and again, these are both right angles, and that's 350 feet. And those are degrees. Okay, so what's important about this is based on this triangle, I can write this trigonometric ratio. So I was looking for these triangles. So I was either looking for them separated or the student having the triangles in there. And again, you could have done these triangles down here. Then I needed to have them equation represented. So therefore, I should have seen tangent of 4 degrees is equal to 350 feet divided by D2, and tangent of 6.5 degrees is equal to opposite, which is 350 feet, over D1. Now you could have written them like this way, or you could have actually solved for D2 and D1, which I'm kind of running out of some space here. But anyways, when you go ahead and calculate this, so I'm not going to, well, I guess I go ahead and solve from this. Let's just go ahead and write this. So if you're to solve for D2, that's basically actually going to be 350 feet divided by the tangent of 4 degrees, which was 5,005, I believe. And then I stored this in my calculator. And then D1, let's do this. So then D1 was actually 350 feet all over the tangent of 6.5 degrees. And that ended up being 1,933. And again, these are like feet. Now, again, I rounded these. I asked my students to round to the nearest tenth. So therefore, when I did D, which was my final answer, which I'll just kind of put over here. Sorry, this is a heavy problem. So D, no, that was not incorrect. I actually didn't solve that one. My bad. Let me actually erase that. Let's figure that one out. That is wrong. Let's do 350 divided by the tangent of 6.5. That was 3,071. And again, obviously this is, I'm just giving a rounded answer because I used the full stored answer. So when using the stored answer in my calculator, I ended up getting 1,933.3 feet. So that was the correct answer. And then, so what I was looking for is the answer. I was looking for D was defined either in a long sentence or D was defined either in a sentence or from there. So I probably shouldn't have shown these extra triangles, but kind of ruined my space for working. But hopefully you got at least these two answers. That looks really bad, but that's 5,005 feet and that's 3,071 feet. And then obviously those are stored in decimals. And then basically I subtracted them. I subtracted D2 from D1 to get me D, which is 1,933.3 feet. You know what? I might as well just, what did I get that? Oh, crap. Clear. 31 point, let's see, that's 3,071.9. And then this was 5,005, what, 0.2. There you go. So there are at least you can kind of see where I got those decimals for you. All right, so the next one says the angle of elevation. So again, when we're looking for angle of elevation, we have a horizontal. So this one was kind of confusing for a lot of students. So they also had a trouble with the angle of elevation to the top of a TV antenna mounted on top of the Eiffel Tower. I think there's such a lot of tops, right? But again, you're thinking about you have a TV antenna mounted on top of the Eiffel Tower. So again, I'm just going to draw a tower, right? And then let's just draw an antenna, whatever looks like that. Okay, maybe we'll put a little dot there. All right, so we have an angle of elevation. So the angle of elevation to the top of a TV antenna mounted on top of the Eiffel Tower in Paris is measured to be from the base of the tower. So again, you can see that our horizontal here is going to be the base from the base of the tower, which would be like the ground. So an angle of elevation has to be above the horizontal. Now, we also need to understand what is 80 degrees, 1 minute, and 12 seconds. Well, again, that is really 80 degrees plus 1 minute out of 60 plus 12 seconds out of 3,600. And again, that's how many 60 minutes make up 1 degree, 3,600 seconds make up 1 degree as well. And when you go ahead and do this, you get 80 degrees. Oops, I'm sorry. You get 80.02 degrees. So that's all you really need to figure out. When you do 1 over 60, let me just double check it. 1 divided by 60 plus 12 divided by 3,600. Yep, 0.02. So your degree that you're really plugging into your calculator is just 80.02 degrees. So all we need to do is convert that to decimal form. And we know that this length is 185 feet, and this was your height. So we're basically looking for h, which is how tall is the tower plus antenna. So h equals the height of tower plus antenna. Okay, so now we can just create a trigonometric ratio here. I can just write the tangent of 80.02 degrees is equal to opposite over adjacent. So that worked as an equation, or what I was trying to show you here, like you could have given me this equation or you could have given me this equation. Like either one of those equations work, right? So if you would have given me this equation, then give me the answer, that's fine. Or if you would have done one more step and showed me this equation, that would have been fine as well. But I was just looking for one equation, and the answer ended up being 1,501.3 feet. Okay. All right, let's look at number 3. So number 3 says two fire lookout stations are 10 miles apart. So we have 2 miles apart, with station B being directly east of station A. Now again, we don't really have any bearings. We just know that one is going to be east of the other one. So let's just go ahead and write this here. So let's say station B is directly east of A. So that means here's A, and let's do B. Okay, and we know that their distance is 10 miles. All right, now that's all we know at this point. Both stations spot a fire. The bearing of the fire from station A is going to be north 24 degrees east. So let's go ahead and create a bearing. So from A, we have north 57 degrees. North 24 degrees east. I was like, that's not going to make any sense. So that's going to be like this. That old 4. All right. And so the bearing from station A is north 24 degrees, and the bearing from station fire, to the fire. And, okay, so that's going to be the bearing to this fire here. And the bearing of the fire from station B is going to be north 57 degrees west. So let's go ahead and create a bearing here. So then from there, it's 57 degrees west. All right. How far to the nearest tenth of the mile is the fire from each lookout? Okay. Well, the nice thing about having these two angles is we can figure out what the angles are on the interior because using complementary angles. So 24, so 90 minus 24, that is going to be 66 that I have. Yep, 66 degrees. And this one is going to be 33 degrees. So a lot of students did the law of cosines with 24 and 57, but again, those aren't inside of the triangle, right? We got to use 66 and 33. So again, we're going to be looking for our angle B as well as our angle A. So A represents the distance from station B. Now, again, you could label these however you wanted to, and I had to check with students. Typically, if you remember when we set up our triangle, this could be kind of confusing, right? So, like, how we want to label them depends. Like, typically when we're doing oblique triangles, we would say opposite side, or the angle and the opposite side all have the same letter, right? So that's fine if you want to do it that way, which to me kind of makes more sense to keep things like consistent. But then we just need to say that A equals the distance from station B to fire. Is that what I did? Yeah. And B equals the distance from station A to fire. So it's a little confusing that way, but again, I think it'd be also confusing to, set which way you want to look at it as well. So now let's go and see here. Now, do we have a ratio? Well, we don't have a ratio yet, right, to the law of sines. However, we can figure out what this third angle is just by using the interior angle sum theorem of triangles. And when you add these all up, you could say 66 plus 33, then that equals to be 21. Now, I didn't do it that way. That's kind of interesting, but I just want to make sure that I do that. So again, basically, you can take 180 degrees, and let's call this F. Or, yeah, let's call it F, which is the fire, right? So then this would be little f. So that'd be 180 minus 66 minus 33. And we get 81. Okay, so that's how you find F, which is 81 degrees. Now, we really don't need to use the F and the little f because we're going to be setting up the law of sines. And we're going to be solving for A and B. So therefore, I can say A over the sine of 66 degrees is going to be equal to 10 miles over the sine of 81 degrees. And then the other equation you needed was B over the sine of 33 degrees is equal to 10 miles over the sine of 81 degrees. Now from here, you could multiply by the sine of 66 on both sides. You'd multiply here by the sine of 33 on both sides. And you'd go ahead and solve. And when you do that and then round to the nearest tenth, I got A to be 5.5 miles. And no, I'm sorry. I got B. That was B. So B was equal to 5.5 miles, and A was equal to 9.2 miles. Okay, so again, just basically solving for those angles, which we went over and over and over again in class. So hopefully I can just kind of, hopefully expect you guys to be able to type that into your calculator and get that one right. All right, so the next one. Now this one, actually, I did make a mistake. So crap, I kind of forgot how I wrote that. I remember what the triangle looks like. So how did I write in here? Yeah, island C. This was supposed to be a C. Okay, that was a change that I made with my students. All right, so this one reads, Island A is 6 miles. Was there anything else? No. Okay. Island A is 6 miles west of Island B. Island C is 7 miles. Okay, well, hold on. Let's slow down. So we have an island, right? Island A is west of Island B. So let's just put A here, and that's 6 miles west of B. So let's put B here. Okay. Island C is 7 miles. Island C is 7 miles northwest of B. So, again, now we have a bearing. So here's north. So we have northwest. So we're going to say northwest is somewhere in this direction. Now, again, it doesn't say to, accept that to be like 45 degrees. It just says it's in that direction. And that is Island B and so that's 7. And Island B is of Island B and 5 miles northeast of Island A. So it's 5. So Island C is 5 miles northeast of Island A. So that's going to be, again, doing your bearings, northeast, right? So this one was the northwest. We don't know the angle. That's northwest. That one's northeast, but that's 5 miles. And let's just call this Island C. So basically what you guys notice is we have a triangle, right, which is the law of cosines. If you need to travel from one Island A to Island C, so Island A to Island C, so A to Z, what bearing would you need to take? Now, the nice thing here is we're finding the largest angle, so we're not worried about the ambiguous case, or having like an obtuse angle here. So all I need to do here is just go ahead and set up my law of sines. And I provided students with this formula on their formula sheet. So they basically had the cosine of A is equal to B squared plus C squared minus A squared all over 2 times B times C. And then I just needed them to basically type this stuff into their calculator, which would have been B squared, which is 5 squared, plus 6 squared minus 7 squared all over 2 times 5 times 6. Okay, and then when you go ahead and type that in and then use the cosine inverse, you get A equals 78 degrees because I had them round to the nearest whole. So that means this is 78 degrees, and I can't tell you how many students gave me that as the bearing from A to B. But again, the issue, guys, is that is not the bearing. Bearings start from due north. This is what we're looking for. We're looking for this angle. So the problem with that is that's not 78 degrees. This is 78 degrees. We got to look for this angle, which is the complementary angle. So therefore, we could say it is a bearing of 12 degrees, or you could say north 12 degrees east. Okay, either one of those would have worked. All right, so I'll take a quick little break here just to kind of check, see if anybody has any questions. Do see some people come in here. Randy, Edison, Victoria, Silly Bean, good to see you guys here. Amnisa, thank you. I do apologize. I'm trying to run through, see if there's any questions for you guys. I apologize. I'm not going to be able to get any questions, but I will be back tomorrow around the same time, 9:30, and therefore I will be able to help you. If you guys do have any questions, again, I'll be happy to do a little bit more time on that. I still got to kind of grade some papers tonight to kind of get caught up. Jasmine, my favorite teacher, but you're not really my teacher. Well, very happy to help you, Jasmine. Any way I can to be able to there. All right. Well, I guess nobody has questions. You guys are just getting in on the chat, which is very cool. Awesome. Somebody make my channel too. All right. That's all right, Kitty Gamer. I don't think you actually did too bad. So, mostly as long as you're showing your work, I can see your thought process, and that's the thing with these, a lot of these problems can be kind of difficult, right? But again, I was looking for two things. I was looking for the triangle, the equation, and then the answer. And a lot of people didn't get the answer right, but I could see that they had the correct thinking, and that was most important. Now let's kind of get to the word problems here. Or I'm sorry, the multiple choice, since I didn't see anybody else get to this. Okay. So I'll get to this. As I mentioned, guys, I'm going to kind of try to keep this stream here kind of short. Once I'm done with this, then I will, I'm going to kind of sign off, not really do some homework problems, but then I will be back tomorrow for some more stuff. So this one says a sailboat leaves port on a bearing of south 72 degrees west. So what I'm going to do in this one is I'm actually going to draw this down below because these, I don't have enough room. So here's my bearing, right? So north, east, south, west. So that says I am flying on a bearing of south 72 degrees west. So south 72 degrees west. So 72 degrees, that's probably going to be somewhere like that. Okay, so there's my 72 degrees. All right, and it says after sailing for 2 hours at 12 knots. Now, again, 12 knots is going to be nautical miles per hour. So therefore, you have traveled 24 knots, so that's going to be 24 nautical miles. The boat turns 90 degrees toward the south. So again, this is very important. If you turn 90 degrees, that means you have created a 90-degree triangle. That's very, very important. We have just created a 90-degree triangle. So therefore, automatically in my brain, so this is 24 nautical miles. Okay, but we've just created a 90-degree angle. Now it says toward south. It doesn't say due south because that would create a 90-degree angle. It just says towards. But the main important thing, guys, is it just told us to create a 90 degrees. So we don't need to worry about law of sines, law of cosines. We can use trig. All right, and then it says after sailing for 3 hours at 9 knots on this course, what is the bearing of the ship from the port? So that's very important. We need to be able to figure out what is the bearing of the ship from the port. Okay, so rounding your answers to the nearest tenth. So 9 knots is going to be, for 3 hours, that's going to be 27. Okay, so maybe we went a little bit farther, let's say to there. All right, now that's where you're at right now. So now we don't know. Are you here? Are you like here? Are you here? Like, we have no idea. All we know, though, is we are looking for this bearing back from port. So what we need to do is figure out this angle, because this angle could be less than 72 degrees. It could be larger than 72 degrees. But what is this purple angle? We know the blue angle, right, is 72 degrees. But what's the purple angle? So let's go ahead and set up a trigonometric relationship here. So this angle, let's just call this theta. So therefore, I can say, well, tangent of theta is equal to opposite, which is 27, over 24. And again, these are nautical miles, but it doesn't really matter. Theta is going to be our angle, so that's going to be tangent inverse, which again I did, but I guess I didn't write it as 48, I believe. So let's just go ahead and do tangent inverse of 27 divided by 24. Yep, 48. So round to the nearest whole, which has to do is 48 degrees. Okay, so if this is 48 degrees, let me actually change that. Theta equals 48 degrees. So if that's 48 degrees, I need to figure out then what is this bearing, right? Here is, or actually it's 48.3. 366, right? So you can go ahead and save that. So that is what it is from there to there. But again, I'm looking for this bearing right here. So basically this angle, which is going to be my bearing, is going to be, so my bearing, which I'll do in red, bearing is going to be 72 degrees minus my theta. So I'm just going to do 72 minus that last answer. And I get 26.63. or 26.6. So again, that is my angle. So it's going to be south 26.6 degrees west. So south 26.6 degrees west. And let's see if that is one of those answers. South 26.6 degrees west, which is answer B. But again, to get that answer right, I needed to see the equation. So I asked students when they're doing these problems to make sure that they showed the equation for this. Because again, it says, what is the bearing to the ship from the port? So that's what we're looking from the port down to the ship. All right, the next one is a 25-foot ladder just reaches the top of a house and forms an angle of 41.5 degrees with the wall of the house. So the main important thing is it says you're making an angle with the wall of the house. So for this one, I can actually draw. So like here's a ladder, here's your house. It's making an angle with the house at 41. Oops. 41.5. And then again, we can create a right angle here. It says a 25-foot ladder. And how tall is the house? So let's put that as T. Let's not use T. Let's use H for height. So now we got to figure out, well, which trigonometric relationship, again, should I be using here? Why did I use... Oh, crap. Did I get that one wrong? Hold on a second. How tall, a 25-foot ladder just reaches the top of a house and forms an angle 41.5 degrees. Oh, yeah, I'm sorry. With the house. How tall is the house? So then here's your angle. So again, we have the adjacent side and the hypotenuse. So your trigonometric equation that you should have used is the cosine of 41.5 degrees is equal to adjacent over hypotenuse. And therefore, when you multiply by 25 and take the cosine of 41.5, you get 18.7. So that was your equation. That's your triangle. And there's your answer. All right, the lovely ambiguous case. So remember here that alpha represents the angle for A, gamma represents the angle for C, and beta represents the angle for B. Now you can see here that we have these prime here. So that means that's the second case solution. So what I did in this case is I drew a random triangle with my angle B. And let's go ahead and figure this out. So I have B. And I said this was A, and then let's make this C. All right, so angle A, or this was 9.43. B was 5.69. Is that supposed to be a 3? That was supposed to be a 3. Let's just get rid of that. Looks so ugly. Okay, 9.43, 5.69, and then we have B, which is 11.6. So I need to figure out, well, basically, I want to figure out what A. So if I can't figure out, let's go ahead and solve for A, because these two have the same A's, right? So if that works, then I know it's either going to be A or D. So I'll go ahead and set up a relationship here for the sine of A. So I'll say sine of A over 9.43. is equal to the sine of 11.6 degrees all over 5.69. And when I solve for A, I ended up getting 19.47. So good. So that means that one doesn't work and it's not that one. Now, this works, right? Or we also got to check, well, what about that A prime? What about that second solution? What about like A2? If you remember me talking about this, that second option. So what I told students to do for that, to figure out if there is a second case, is to take 180 degrees and subtract it from A. And so basically when I did that, I take 180 minus 19.47, and I got 160.53, which is my second triangle. And that works because 160.53 plus 11.6 is 172.13. Therefore, there's enough angle for another angle of C. So this one actually has two triangles here. So therefore, 7 is, or two cases, is going to be the correct answer on that one. All right, the next one is determine the number of triangles with the given parts. So in this one, it's another law of science, but now it's just saying how many triangles are there. So typically what I'll do in this case is I'm just going to kind of draw the triangle, and then I'm going to use the height in this case to really determine what it is. So let's just kind of draw my triangle here. Let's say here's alpha, so that's 72 degrees. Opposite of that is 32. And then let's make this B, so therefore B is 65. Okay, so therefore the height of this triangle, actually I'll do that in blue. The height is equal to 65 times the sine of 72 degrees. And actually, did I calculate that? Yeah. So when I calculate that, I get 61.81. Well, guys, it's not possible for our opposite side to be shorter than the height. Again, that triangle would look like this, right? So if your opposite side is shorter than your height, you can't form a triangle. So therefore, there are 0 triangles that can be created in this one. The next one has a whole bunch of blah, 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 blah. These were decimal points. I don't think anybody got it wrong, though, because of that. But basically you have the triangle here. So there's all this stuff here, and then, but basically you just have the triangle. And we can see here that this is a side angle side. This is going to be a law of cosines problem. And looks like we're going to be solving for the side length C, right? That's what we're looking for. So therefore I just created the equation. So I'd rearrange my terms, and I just did C squared equals 90.8 squared plus 60 squared minus 2 times 90.8 times 60, and then times the cosine of 119 degrees. And therefore, when you go ahead and multiply, and then you take the add, and you blah, 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 you take the square root, you're going to get 130.9 feet. So there you go, ladies and gentlemen. That is going to be the quick little quiz, as I mentioned a couple times over and over. I'm going to keep that one brief. I am now going to go ahead and upload this, though, onto my memberships for any of you guys that want to kind of get access to that aren't in my class or not a members. And then also just a reminder, I'll be going live tomorrow. So if you have questions in that area, you can post them. I'll also go ahead and make I probably won't do it till tomorrow, a nice little chat in my Facebook group if you want to go ahead and post any comments for questions. And then tomorrow I should have some more work or some more time after I go over the homework, which will be on vectors. And just to give you FYI, we're doing vector homework this week. Next week is going to be parametric and polar equations. And then we're going to get into a test, and then we got spring break for us. So that's kind of how the rest of the next couple weeks are going to my class. But otherwise, hope you guys are doing well. And then I will see those of you that check in tomorrow. All right. Cheers.